Now here we have this question here, and it says that f of x is equivalent to 3 into 2 minus x, then all over 1 minus 2x, 1 minus 2x raised to the power of 2, and 1 plus x, okay? And we are told here to express f of x in partial fraction, and hence show that the integral of f of x with the upper limit of 2 and lower limit of 1 equals 1 minus ln 2. Now let us start. Now first of all, we need to split this compound fraction to its component fraction. So how do we do this? So here we have, now considering the denominator, we can see here we have a repeated fraction. A repeated factor rather. So here we get to have 3, then into 2 minus x, then all over 1 minus 2x all raised to the power of 2, then into 1 plus x, okay? So we get to have, for a repeated fraction, here is the principle. Here we have a, then all over 1 minus 2x, okay, plus b, 1 minus 2x all raised to the power of 2, then plus c, then 1 plus what, x, okay? All right. So now take note that the factors in the denominator is similar to or is equals to the factor on the right hand side, okay? So here we get to have, okay, let's find the LCM, which is the same thing as the factor on the left hand side. Here we have 1 minus 2x all raised to the power of 2, then into 1 plus what, x, okay? So we're actually looking for it an equivalent of the numerator that aligns with 3 into 2 minus x. So here we have 3 into 2 minus x all over 1 minus 2x all raised to the power of 2 into 1 plus x, okay? So this divided by, we have to take the fraction one by one. So this divided by this, now we get to have one of these remaining and this one. So here we have a, then into 1 minus 2x into what, 1 plus what, 2x, okay? That is, you might be wondering, how did I get that? So here you have 1 minus 2x all squared into 1 plus x all over 1 minus 2x. Now when we eliminate this, so we're left with what, 1 minus 2x, then times a now give us what I've just written on the board, okay? Now the same thing apply to b. So b, here we have b, this we eliminate this, we are left with 1 plus x, then plus, then c, the whole of this we eliminate the whole of this, here we have c into what, 1 minus 2x all raised to the power of what, 2. Okay, now since we have the same numerator here, denominator and denominator, so can just cancel out. So we are left with 3 into what, 2 minus x, then equals a into 1 minus 2x, 1 plus x, then plus b into 1 plus x, then plus c into 1 minus 2x all raised to the power of what, 2. Okay, now let us take each of this term, equate them to 0, so I will get the value of x for each factor. Then we substitute that value to find the value, we substitute that value into the equation to find the value of a, b, and c. So let us start with 1 minus. So 1 minus 2x will give us 0. Okay, that is, we will equate it to 0. So at the end of the day, our x will give us 1 over 2. Okay. Now for 1 plus x, we put to 0. So here we have that our x will give us what, negative 1. Okay, and we can also put make x equals what? 0. Alright, now let us start with x equals 0. For x equals 0, now opening this bracket here, if you have to open this bracket, we end up having 6 minus 2x. Okay? Alright, so plugging in 0 for x in the equation, we get to have, this one becomes 0, right? That will be 6 minus 0, then equals, now let us be careful here. So if you plug in 0 here, this one becomes 0, x is 0, x 0, and x 0. So we are left with a and 1. So that will give us a. Now b and 1 will give us plus b, and c and times 1 will give us what? C. So this will give us 6 equals a, b, and c, which is what? Equation 1. Now for x equals minus 1. So here we plug in the value of x for minus 1 into the equation. So here we have that 6 minus 2 into minus 1, then equals, now for here, if we plug in minus 1 here, this one becomes 0, because 1 minus 1 will give us 0. So 0 times the whole of this, all this become was 0. So here we have 0. Then plus, if we plug in minus 1 here, 1 minus 1 will give us 0. 0 times b will give us was 0. Then plus c. Now if we plug in minus 1 here, that is 1 minus 2 into minus 1. This will give us 1 plus what? 2. Okay? So this equals what? 3. Now 3 raised to the power of 2 give us what? 9. So here we have what? 9c. And here we have 6 plus 2, right? Oh, sorry. This is 3. Sorry. This one should be 3. Then here we have 3 equals 9c, giving us 9 equals 9c, and our c here equals what? 1. Okay? Now let's make x equals 1 over 2. Okay? Alright. Now plugging in x equals 1 over 2. For this we have 6 minus 3 into 1 over 2, then equals 1 over 2 here will give us 1 minus 1, we should make this one 0, and the same thing here, put 1 over 2, this one give us 0. So we are left with b, then into 1 plus what? 1 over 2, then which will give us is 6 minus 3 all over 2 equals 3b all over 2. Now here we get to have 12, that is 2 times 6, or you'll find the LCM, which is this one is equal to 1. The LCM here is 2. Now 2 in 1, 2 times 6 is 12, minus 3, 2 in 2 is 1, times 3 is 3, then equals 3b all over what? 2. So here we get to have, now since we have the same numerator, this one will eliminate this. Here we have 9 equals to 3b. At the end of the day, our b is equals to what? 3. Okay? Now after which, now we can come over here and see, come here, since we've gotten b to be 3 and c to be 1. So let us plug in this value into equation 1 here. So we get to have that 6 equals a plus b plus c. Then 6 equals, our a is, okay, we are looking for a, then plus our b is 3. Now our c is 1. So we get to have that 6 equals to a plus what? 4. Thereby making our a equals 2. That is 6. When you bring 4 back to the left hand side, it becomes 6 minus 4, which is what? 2. Okay, so this whole component fraction here, it then gives us 3 into 2 minus x all over 1 minus 2x all raised to the power of 2, 1 plus x, then gives us a is 2, we have 2 all over 1 minus 2x, now plus b is 1, right? b, okay, b is 3, 1 minus 2x all raised to the power of 2, then plus c is 1, then all over 1 plus what? X. Okay, now here is the partial fraction of f of x. Now we're now to show that the integral with upper limit of 2 and lower limit of 1 will give us 1 minus ln x. Now what we need to do now is to integrate this, and by integration we get to have 2 all over 1 minus 2x, then plus 3 all over 1 minus 2x all raised to the power of 2 plus 1 all over 1 plus x, and take note this is 2, 1, then dx. Okay, now first of all what we need to do now is let's take it this way. Let's just put aside the limit, the upper limit and lower limit. Let us have the integral of 2 all over 1 minus 2x, then plus the integral of 3 all over 1 minus 2x all raised to the power of 2, then plus the integral of 1 all over 1 plus what? Okay, now for us to integrate this now, just looking for a more simpler way. Now take note this is dx here and dx here. Now if you are to integrate this now, okay, let me just do a quick one here. Okay, let me just do a quick one here. Now for us to integrate this, so here we have 2. Okay, now first of all, let's say let u be equals to 1 minus 2x, then du dx will give us minus 2, right? Now making the x destroy the formula, we have that dx equals minus du all over 2. Okay, alright. Now replacing the x for du minus and this as u, so you get to have 2 all over u, then times minus du all over 2, just using this as an instant, which is the same thing with all. So, and here we get to have this 2 here, eliminate these 2, so we are now left with the integral, let me say minus 1, which is this minus, then integral 1 all over u du. Okay, and when you're integrating 1 all over u or 1 all over any term, you get to have ln. So here we have minus 1, this one give us equals minus 1 into ln u, okay, plus, so which will definitely give us minus ln, then our u is 1 minus 2x, okay, plus c. Now if we apply this principle to this, it will definitely still give you the same one here. Let us have it as now the integral of 3 into 1 minus 2x all raised to the power of 2 dx. Okay, now I just have this to be the integral of, let me see, 1 over 3 bring out this factor out, I mean the term 3 constant. So you get to have, and put this in put the denominator in index form. 1 minus 2x all raised power what minus 2 dx. Okay, now you see here, let u equals 1 minus 2x. Okay, so du dx, we get to have minus 2, and dx will now give us minus du all over what 2. Now here we have 3, the integral of u all raised power minus 2, then times minus du all over what 2. Alright, so to this end, this is same thing as saying bringing out this minus 2 here, then you have minus 3 all over 2, the integral of u minus 2, then du. Now integrating this, we get to have minus 3 all over 2. Now we have I take note, this will be u minus 2 plus 1 all over minus 2 plus 1. Okay, so now this will give us minus 3 all over 2, then into u raised power minus 1 all over minus 1. Okay, now minus will multiply this one. Now we get to have 3 all over 2 u raised power what minus 1 plus c. Okay, and that's for this. And for this one, just a simple way, the integral of 1 over 1 over x, 1 over 1 plus x, the x, this is just straightforward, equals to ln 1 plus what x, then plus c. Alright, and let us bring everything together. Now here, this one will have minus ln into 1 minus 2x, then plus, here we get to have, okay, putting this in normal term here, that will be 1 all over our u here, 1 minus 2x. Okay, so here we have 3 all over, opening the bracket there, you have 2 plus 4x, then plus ln 1 plus what x. Okay, now let us now apply the limit to 1. Now it implies here that for the value of x, for x, plug into whatever value you get, minus plugging in 1 also for x, minus the value you get to have for putting in x equals to what 1. So the value or the term you get plugging in 2 minus the value or term you get plugging in what 1 for x. So let us solve the one for 2. So it implies that wherever you see x, plug in 2, and let's evaluate. So here you have minus ln for 2, 1 minus, for 2 here we have what 4. Now take note, we'll be taking the absolute value. Okay, so here we get to have then plus, then 3, then all over 2 minus, here you have 8, then plus ln 1 plus 1 plus 3. Sorry, 1 plus 2, that will be what 3. Okay, so here we actually take the absolute value of minus 3 here. So you have minus ln 3, then here you have minus 3 all over, here you have minus 6. Okay, that will be 6 rather. Okay, now plus ln 3. Now this is for 2. Let me just make this one like or let's just make it 1. So for 1 here, plug in 1 for x in the equation. So you get to have minus ln 1 minus 2, or 2 times 1 will give us 2. Now take note, we are actually taking the absolute value of whatever we get in the bracket here, and that's for only for the ln. Okay, then plus, then here we have 3 all over 2 minus 4, because 1 times 4 is 4. We have minus 2, then plus ln 1 plus 1 here will give us what? 2. Okay, so here we have minus ln 1, because we are taking the absolute value, then minus 3 all over 2 plus what? ln. Now take note, these two. So the whole of this minus this. So we get to have minus ln 3 minus reducing this fraction, we have 1 over 2 plus ln 3, then minus the whole of now this one actually becomes 0. Okay, ln 1, because log 1 is 0. So let's that one say you have minus 3 all over 2, then plus ln 2. Okay, all right, now opening the bracket, we have minus ln 3 minus 1 over 2, then plus ln 3. All right, now minus times minus will give us plus 3 over 2, minus times this plus will give us minus ln 2. Now do you have a common term here? Minus ln 3 plus minus ln 3 will eliminate. So here we have minus 1 all over 2 plus 3 all over 2 minus ln 2. Now, and if we find the LCM of this, we end up to give us 1. So we end up having 1 minus what? ln 2. Alright, we've now shown that the f of x, the integral of f of x with the limit of 2 and 1 equals 1 minus ln 2. Alright, this is the solution to this question, and if you love what I've just done, subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and mathematics. Thank you, and God bless you.